Today we're doing 7.6 linear shifts. Because this is linear, we're going to write the basic form, the general form of a linear function, which is y equals mx plus b, where b represents your y-intercept and m represents your slope, which is why that's called slope-intercept form. So on this first line, our parent function, y equals x, it has a y-intercept of 0, 0, and an x-intercept of 0, 0. So the rest of the problems on this page, we're going to be exploring what happens to your line when we add or subtract from different parts of the equation. So our second one, we have y equals x plus 3. So now we know that the y-intercept is 3. So I can start with the dot there. And our slope is the implied 1 in front of x. So we can rise 1, run 1, rise 1, run 1, and draw our line. So when we compare this to the original graph, we know that it shifted up 3 units. So we're going to put up 3. And our x-intercept is over here at negative 3, 0. The next one, we have an x minus 1 in parentheses. So when we dealt with quadratics, when it was in the parentheses, it changed your inputs, but it was always the opposite of what's happening. So we're going to explore that on this one as well. Because there's an implied positive 1 outside the parentheses, they don't really matter, but for when we graph it. So we're going to go ahead and graph it with a y-intercept of negative 1. Because our y value, or our b value, was negative 1. And then it still has that slope of 1, so we're going to rise 1, run 1, rise 1, run 1. But because the change is inside of the parentheses, we want to look at how it's affecting the x values. So our parent function goes through the origin, whereas this line goes through 1, 0 on the x-axis. So therefore, that line was shifted right 1. So again, in the parentheses affects your inputs. And we talk about left and right because like your inputs, that's how your x values change, is from left to right on its axis. So this one is outside of the parentheses, this fourth one. So our y-intercept is 0, negative 5. We still have a slope of 1, so rise 1, run 1. And because that minus 5 is outside the parentheses, we want to talk about what's happening to the output, your y values. Y values are always up and down, so because this one's subtracting and because it moved down on our graph, we're going to write down 5. And our x-intercept is now over here at 5, 0. So now what happens when our slope is larger than 1. So just like with quadratics, when we had an a value that was larger than 1, it created a vertical stretch. So we're going to write that for this one. This is a vertical stretch with a scale factor of 2. So because there's nothing added on to the end, our y-intercept is still 0, 0. But now we have this slope of 2 over 1. So we're going to rise 2, run 1, because it makes our line twice as steep. And you can draw your line from there. So because this didn't shift our line left or right, the x-intercept is still the origin, just like the y-intercept. It just made our line stretch vertically, which made it twice as steep because of the coefficient 2. So when we looked at quadratics and the a value was negative, it was a reflection over the x-axis. So it's the same for linear. This is a reflection over the x-axis. So we still have that same y-intercept of 0 because there's nothing added on to the end. But because this was reflected, instead of going up and to the right, now we're going to go down and to the right. So that it is a reflection of the parent function. Also, because if you look at your equation, we have a slope of -1. So the next one we have is, wait, did we? Nope, we didn't do our intercepts. So our intercepts on this one are, it's going through the origin. So your x and your y-intercept are both 0, 0. So our next one, this one we have several things going on. So we know our parent function, and I'm going to draw the parent function to help be a guide. You don't have to do that on all of them. I did, but you don't have to. So here's my parent function, y equals x. So now it tells us that we're going to move this line. It's going to have a horizontal stretch of 1/3. Now, it's also got an x plus 3 inside the parentheses. So just like with quadratics, when you look at the inside, your formula actually says x minus a number. So in order to turn x minus a number into x plus a number, that number has to be negative. So change your thinking when you're looking inside the parentheses. So this plus 3 is actually telling us left 3. So inside the parentheses affects your inputs, your x values, which are left and right. Outside the parentheses is your outputs. So it affects your y values. So we're going to go down 1 because like your y-axis is up and down. So at this point, we're going to look at the y-intercept of your original, your parent function. And we're going to take it left 3 and down 1. So our new parent function, our new original point. So I looked at that y-intercept. So it moved left 3 and down 1, and it gave us that new point. Now we have to apply that horizontal stretch with a scale factor 1/3. So it's just like your slope. So we're going to go up 1 and to the right 3 to find other points on your line. And there's our new line. So although it shifted in different places, our y-intercept still ended up 0, 0. And our x-intercept is also 0, 0 because the line goes through the origin. All right, and then the next one. Again, I'm going to draw the parent function because sometimes it makes it easier to see all the different changes. So, first things first. We know that this has a negative value at the front. So the negative is what tells us that it's a reflection over the x-axis. I'm going to change one of my colors. Let's see. Let's keep that. So the negative tells us it's a reflection over x-axis. The 4 tells us that it is a vertical stretch by a scale factor of 4. There's nothing happening inside the parentheses, so nothing happening to the inputs, which are your x values, left and right. There's only a number outside of the parentheses, which affects your outputs. So plus 4 is up 4. So we have our parent function. And I'm going to take that and I'm going to go up 4. And then I need to reflect it. So now I know it's going to go down instead of up. And it's going to stretch by a scale factor of 4. So instead of it going down 1, right 1, we're going to go down 4, right 1 because of that vertical stretch with a scale factor of 4. So our next point is actually going to be right there. So that takes us down 4 and to the right 1 to represent that vertical stretch. And the reason it's down is because of that reflection. So again, I moved it up 4, which would put us at this line. If all I did was moved it up 4, it would be here. And then when you reflect it, it ends up there. But then you have to apply that scale factor 4, which makes it that steeper green line. You could also graph that based on y equals mx plus b, but you do need to be able to point out the different transformations that are happening. So our y-intercept is now 0, 4, and our x-intercept is 1, 0. So now we're going to do some comparisons. So on the left, they're all linear. On the right, they're all quadratic. And the way you know that is because the linear has no exponents. So each of these on the left is linear because there's no exponents. And on the right, because there's a 2, when it's a 2, it's a u. So each of those are quadratic. And that's because it has an exponent 2. So the first one, how they're similar. They both have a leading factor of 1/2, which means that the a value is 1/2. That means they have a horizontal stretch by a scale factor 1/2. Now inside the parentheses, the inputs are changed. And remember, when it's inside, you change your thinking because it's not going the direction your brain wants you to tell you it. So when it's plus 3, it's actually moving left. So it's a translation left 3. So the only difference between those is that one is linear and the other is quadratic. So then if we look at the next two, we have that negative in the front, which represents a reflection. And then we also have these -3s. They're outside the parentheses, so they affect the outputs. Outputs are your y values, which are up and down. So because this is -3, it is a translation down 3. And again, the only difference is the one on the left is linear, the one on the right is quadratic. the next two. So they both have an leading factor of 5. So this is a vertical stretch with a scale factor of 5. And a vertical stretch is also a horizontal shrink. A horizontal stretch is also a vertical shrink. We'll write that down in a little bit. So then looking at the next thing going on is inside with your inputs, you have a +4. So that is a translation. Remember, we change inside, so it's left 4. And then there's a +2 on the outside, affecting your outputs. So it's up 2. And again, the only difference is the one on the left is linear because there are no exponents. The one on the right is quadratic because there's a 2 in the exponent. All right, last one. There is no leading factor up front. The only thing happening in this is on the inside. So it's affecting your inputs, which is left and right. So on the inside, you change your thinking. So this is a translation. Right 19. And again, the one on the left is linear because there is no exponent. The one on the right is quadratic because there's a 2 in the exponent. So down here, what happens to a line when the number when there is a number higher than 1 for slope? And that is a vertical stretch. Which is also known as a horizontal shrink. And this is where I want you guys to note this. So what happens to a line when there is a number lower than 1 for the slope? And that is a horizontal stretch. Which is also known as a vertical shrink. So at the top of the last page, I want you guys to write something. So another way to think about the linear function is, aside from y equals mx plus b, to make it very similar to your quadratics, is y equals a x minus h plus k. Remember, no exponents is linear. So then when we're talking about quadratic, this is the one we worked with a lot lately. We have y equals a x minus h squared plus k. So a 2 makes a u. 2 in the exponent is quadratic. So now you have to be very careful as you read through these. And honestly, the first thing I did is I went through and I highlighted and I said, okay, quadratic is written there, so I'm going to use this one. The next one says a line, so I'm going to use the linear. Next one, a line. And that way I knew exactly what I was working with. Then, if it helps you guys to do the erase and replace, it's not a bad idea. So we have y, there we go, y equals a x minus h squared plus k. So the first thing I see is it's been shifted 1 unit to the right. So my horizontal shift, h, is 1. And because it's to the right, it's a positive 1 that I'm replacing it with. And then it says, and 5 units down. So instead of k, I'm going to put minus 5. Since it doesn't mention a is going to be 1, and we can simply erase it. So the next one says a line. So we have y equals a x minus h plus k. No squared because it's linear. No exponents in linear. So it's been reflected, which lets us know that the a value is negative. And then it's been moved up 6 units. So we can get rid of that horizontal shift and the parentheses. And then our k value is up 6. So I'm going to change the k to plus 6. All right, we're going to do 2 more together, and then I'm going to let you guys work on the rest. So the next one says align. So we have y equals a x minus h plus k. No exponent because it's linear. Has been vertically stretched by a scale factor of 4. So that means that a value is 4, and it's been moved left 4 units. So remember, left is negative, so we replace that h, we erase h, and put negative 4. Now it wasn't moved up or down, so we're just going to erase that minus k. And we can write this in a prettier method. So we've got, this is the same as y equals 4, and then x minus negative 4 is the same as x plus 4. The last one is a quadratic. So that's the first thing I want to mark. And for a quadratic, it's y equals a x minus h squared, because when there's a 2, it's a u. And then it says it's been reflected. So the first thing we know is a is going to be negative. And vertically shrunk by a scale factor 1/4. So our a value is a negative 1/4. And then it says it was moved down 6 units. So the h value is 0. The k value is negative 6. So because that's a 0, it doesn't matter. So when we do our rewrite, all we have to put is y equals negative 1/4. So reflection and the vertical shrink, x squared minus 6. So I've left 5 on here for you guys to do. Make sure you get on later and check your answers.